Hey, third grade, it's Mrs. Seals back for our next science lab. So we have finished up our unit on energy, and for the next couple weeks, we're going to be talking about something called force and motion. So today we're going to start by talking about force, motion, and position. So we're going to make sure we understand what all of these words mean, and then we're going to do a very fun investigation. So your target says, I can demonstrate and observe how position and motion can be changed by pushing and pulling objects. So hopefully you remember from kindergarten, first and second grade that force is a push or a pull that can change the position or motion of an object or material. So in other words, when I push something or I pull something, it puts it into motion, it moves it, and then that changes its position. For example, I have this box of crayons. It's over here on my right. When I push it, so I'm applying force to it, it put it into motion, and now its position has changed. Now it's on my left. So position is the place where something is located or something has been put. And some words that we can use to describe position are words like above, below, behind, beside, between, in front of, in back of, left, right. All of those explain where something is located or its position. Motion is the change in position of an object. And some words that we can use to describe the way things move or the way the motion is of some objects is round and round, spinning, straight line, back and forth, up and down, side to side, or zigzag. All of those are words that describe the way things move or their change in position. So today we're going to do an experiment to see how position and motion are changed by pushing and pulling. So in this experiment, you're going to see a push, you're going to see a force that also pulls things down to the ground that we're going to mention today, but we'll discuss more in detail next week. This is an activity called ping pong poppers. This is not really an activity that is going to be that much fun for you at home because you probably don't have all of these materials to do this, but it will still be fun for you to watch, and you will still be learning about force and motion and pushes and pulls and position. Okay, so ping pong poppers. This is what we call a popper. You may have seen these before. It's this little rubber kind of half circle, and the way it works is you flip it inside out and you put something in the middle of it and you set it down, and when it releases, it pops. It turns itself inside out, and so whatever's inside of it is going to be pushed up into the air. Okay, so let me do it again, but where you can see it. So you flip it inside out, and you put your object here in the middle, and then you set it down, and when it releases, there we go, it's going to push whatever is in the middle of it up. All right, so that's an example of a push. So the objects that we're going to be pushing are, of course, a ping pong ball. It's called ping pong poppers, right? That's a ping pong ball. Ping pong balls are very light. They're very hollow. They bounce like that, okay? They don't have a lot of mass. We're also going to be pushing up a golf ball, which more mass. It's very hard. It's not hollow on the inside. And then the last thing we're going to be pushing up is a bouncy ball, little rubber bouncy ball. These are Halloween bouncy balls, so they have the little eyeball on them, okay? So we're going to be pushing each of these up with a popper and looking to see which one goes the highest, which one goes the second highest, and which one goes the third highest. We're not going to be able to measure exactly how high they go because in order to do that, we would have to be able to, pause the ball up in the air and run out there with a measuring stick and measure how high it went. That's impossible for us to do. So we're going to be estimating or eyeballing it, which it'll be very obvious because one of these is going to go super duper high, possibly even touching the ceiling. One of them is going to go fairly high, you know, not all the way to the ceiling though. And then one of them is just going to barely get off the ground. So before we do this experiment, and before I have you make a prediction, we are going to measure the mass of each of these objects. So hopefully you remember, think back to the very beginning of third grade, when we were talking about physical properties. One of the physical properties you learned about was mass. I didn't do a video on mass, but I believe Miss Melendez did. And if you'll remember, mass is a measurement of how much matter is in an object. It's not the same as weight, because weight is affected by the gravitational pull. Mass is not. You would have the same mass on Earth as you would on the moon, because mass is a measurement of how much matter is in an object. So to measure the mass of these objects, I'm going to use this tool called a primary balance. Hopefully you remember that when these two sides are equal or balanced, that means we have found whatever is over here has the same mass as whatever is over here. So we're going to find the mass of the bouncy ball first. So I'm going to put it on one side, and then I'm going to use my gram weights to find the mass. I'm going to add gram weights until I have found that both sides are equal. So this is 10 gram weights. I'm going to start with 10. And I don't think they're equal yet, but I don't think I need another 10. So what about a 5? Let me add a 5. That looks like it was too much. Let me take out the 5 and try some 1s. Whoops. All right. So we have 10 in there. Here's 11. Not quite. There's 12. This is stuck. Hold on. Oh, there we go. That's better. What does that look like to you? To me, it looks pretty equal. It looks like that this side and this side are equal or even. So that means the bouncy ball has the mass of whatever's over here. And over here, I have 12 grams because I added my 10 and then 2 1s. So 10 plus 1 plus 1 equals 12. So my bouncy ball has a mass of 12 grams. I'm going to write that down so we don't forget that. All right. There's my bouncy ball, 12 grams. Now I'm going to find the mass of my golf ball. Take my golf ball, put it on one side of my primary balance. This feels like it has a lot more mass, so I'm going to start with a 10. This is also 10. It looks different than the other one, but it's also 10 grams. Start with a 10, not enough. Try another 10, still not enough. There's 30. There's 40. Switch to these 10s. There's 50. Ooh, we got some more movement here. This side looks a little bit higher still, but not maybe not 10. What about a 5? Oh, that was too much. Let me take that out. Switch to my 1s. So we're at 10, 20, 30, 40, 50. Now that I'm looking at it, hold on. All right, now that I'm looking at it, now this side looks too low. Let me take out a 10 and go back to my 5. There's 45. I'm going to try 1s. There's 46, 47. Oh, I think I maybe only need 1 or 2 more grams. 48. That looks pretty good to me. Let's see what happens if I add 49. I think that looks good. What do you think? That looks about equal, right? So we have 10, 20, 30, 40, 45, 46, 47, 48, 49 grams. So that means the mass of my golf ball is 49 grams. Remember, my bouncy ball was only 12 grams. My golf ball is 49 grams. So my golf ball has a lot more mass than my bouncy ball. All right? And the last thing we're going to find the mass of is the ping pong ball, which is the one that is very light. It doesn't have much mass at all. I'll try 5. I don't even know if I'll need 5 though. Oh yeah, 5 was too much. Let's go back to our ones. There's 1 gram, 2 grams. Let's try maybe 1 more, 3 grams. Looks pretty good to me, right? So that means my ping pong ball only has a mass of 3 grams. Whoa, that is very, very light. That is not much mass at all, okay? So let's see what we've learned so far. Ping pong ball, 3 grams. All right. So remember, if we're going to rank them from most mass to least mass, my golf ball has the most mass. It was 49 grams. It is very heavy. It has a lot of matter in it. My bouncy ball had the second most mass. It had 12 grams. Has less mass than the golf ball, but more mass than the ping pong ball that only had a mass of 3 grams. Okay? So I want you to think about this. We're using the same amount of force to push all 3 of these objects up. We're using the same popper, okay? I want you to guess which one of these objects do you think will go the highest? Which one do you think that the popper will be able to push up the highest? Do you think it will be the object with the most mass? That's the golf ball. Do you think it'll be the object with not the most mass, but not the least mass, which would be the bouncy ball? Or do you think it'll be the object with the least mass, which is the ping pong ball? Or do you not think that mass has any effect on this at all? And it doesn't matter how heavy the objects are, that's not going to have any effect. Maybe that's what you think too. Go ahead and make your guess, make your hypothesis about which one you think will go the highest. The most mass, which is the golf ball, middle mass, which is bouncy ball, least mass, which is ping pong ball. Okay, I'm about to do the experiment for you. The kids that are in class will be doing this, and when we do this, we need to be very safe. So for this experiment, we're going to be wearing goggles to protect our eyes. We do not want anyone to get hit in the eye with a ball. All right, so I'm going to kind of move my laptop. I hope that you can see this experiment. This might be difficult for you to see, but you know, we're doing our best. All right, so the first one that I'm going to do is the bouncy ball. We're going to start with the bouncy ball. Remember, that's the one that had a mass of 12 grams. So it has less mass than the golf ball, more mass than the ping pong ball. All right, so I have my popper. I'm going to flip it inside out. I'm going to put my bouncy ball in it. I'm going to come back here to where you can see the ground and the ceiling, because I want you to be able to see how high it goes. Hopefully you can see. So I'm going to put it on the ground, and hopefully, of course, oh, there it goes. It was just kind of sitting there. It took a minute. So I don't know if you could see, but the bouncy ball went about my height, which is 5 feet. So it went about 5 feet up in the air, okay? Hopefully you were able to see that. So that was the bouncy ball. The next one we're gonna do is the golf ball, which remember is our very heavy one. It had a mass of 49 grams, all right? So same thing. I'm folding my popper. I'm putting my golf ball in it. I'm going to set it on the ground and back away. And there we go. So I don't know if you could see that, but the golf ball went about to right here. So it's about it went about 1 foot off the ground. So the golf ball went about here. The bouncy ball went about here. Now it's time for the ping pong ball, which remember was the one that's very, very light. It only has a mass of 3 grams. All right. So, oh goodness. Let's see what happens with the ping pong ball. All right. Folding the popper, putting in the ping pong ball. Give it a second. Whoa! Did you see that? Oh my goodness. Hopefully you were able to see that. And if you were able to see it, hopefully you heard it. The ping pong ball hit the ceiling. It went all the way up to the ceiling. All right? So remember, the ping pong ball had the least mass and it went to the ceiling. The bouncy ball had more mass than the ping pong ball, but less mass than the golf ball, and it went up to about here on me, so about 5 feet off the ground. And then our golf ball, which had the most mass, barely got off the ground. It went about 1 foot off the ground. So I'm noticing that the more mass a ball has, the shortest distance it was thrown up off the ground or pushed. And the least mass a ball has, the higher it went. Let's think about that. Does that make sense? Does it make sense that if we are using the same amount of force to push each object, that the heaviest object isn't going to go as far as the lightest object? It does make sense. We were using the same amount of force. The ping pong ball only has 3 grams of mass. It is very, very light. So the popper was able to push the ping pong ball up very easily because remember, lighter things are very easy to move. And the bouncy ball that has more mass than the ping pong ball but less mass than the golf ball, it was able to push it up fairly high, right? But not as high as the ping pong ball. And then the golf ball that is very heavy and has a lot of mass, the ping pong popper barely got it off the ground because the golf ball is very heavy. Okay, so there's a relationship there. The more mass an object has, the more force it takes to move it. The less mass an object has, the less force it takes to move it. Okay, if we wanted to push all of these objects up to the same height, we would need to change our experiment. And what we would need to do is we would need to apply more force to the heavier objects, either with a bigger popper, either with our hand, maybe a machine that can push them up higher. But in order to get the golf ball and the bouncy ball to go as high as the ping pong ball, we would have to apply more force to them. All right, I hope that you had fun with that experiment. I hope that you were able to see what was going on. Remember that this, science lab is not required. It's just for fun. It's not for a grade. There is a short quiz after this video for you to show me what you know about force and motion and position. I hope that you enjoyed that, and I will see you next time. Bye, guys.